Welcome back everybody, Patrick here. We're moving on to the next question on this test. So Alex is filling the vase below this vase here with water at a constant rate. And we have to draw a graph that would represent the height of the water in the vase versus time as he fills the vase. Okay, so our graph, we're going to have height of water in the vase as the y-axis, and then we're going to have time here as the x-axis. So notice how there's going to be two parts to this graph, because if you remember, we went over this in the lecture videos. When you're dealing with a question like this, it all depends on how the diameter of the vase is changing, whether it's increasing, whether it's decreasing, or whether it is constant. And notice how there's two parts to this vase. So here, in this portion, if we go from the bottom up, the diameter is decreasing for this portion, right? As we go up and up, the vase is getting skinnier and skinnier. So the diameter is decreasing. And then after this point here, the diameter, as we move up the vase, is going to be now increasing. So it's going to be doing the opposite. It's going to start thin and then get fatter and fatter and fatter. Okay, so that is going to affect our height of water versus time graph in different ways. When the diameter is decreasing and we're pouring in water at a constant rate, what's going to happen? Well, the water is going to rise up slowly at first, but then it's going to rise quicker and quicker and quicker because there's less vase to fill as we move up the vase because the diameter is decreasing. And the way we represent that is it would start off slow, 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 and then the speed would increase, right, up until a certain point. Because if we draw slopes of tangents on this curve here, they'll be less steep at the beginning, and then as we move further and further on as time increases, the slopes of the tangents are going to increase, meaning that the height of the water is going to start increasing quicker, which makes sense. That's what happens when the diameter is decreasing. So then here, this point is going to represent this point here at the vase. So now we're going to have another section of the graph, and what's going to be happening here is the diameter is going to be increasing as we're pouring water in. So what's going to happen is the water is going to be pouring quick, fast again, but then it's going to slow down because as we get further up the vase, we have more vase to fill, meaning that the height is going to go slower and slower. And the way we represent that on a graph is it's going fast, 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 but then it's going to start slowing down. So two sections of this height of the water versus time graph. First, the water, or the height of the water, is changing at a slow speed, and then it increases its speed. And then for this portion, it's going to have a fast speed at which the height of the water is changing, but then it's going to slow down. So that's how the height of the water versus the time when we're filling water into this vase at a constant rate is going to look like. I actually want to add a little bonus question that I just thought of to this question here. What if they ask you to draw a volume of water versus time graph? So here was the height of the water in the vase versus a time graph. Here is the volume of the water in the vase versus a time graph. How would this graph look like? Well, if you think about it, the volume of the water has nothing to do with how the vase is shaped. Because if you read the question, they're pouring the water in at a constant rate, meaning that the volume of the vase is changing at a constant rate. So it's just going to be a straight line like this. All right, does that make sense? So the volume is the shape of the vase is irrelevant in terms of how it relates to volume, because we're pouring the water in at a constant rate. So the volume of the vase, no matter if it is shaped more narrow or more wide, or it's a constant diameter vase, the volume is always changing the same way. And because it's being poured in at a constant rate, it's just a straight line that goes up like that. So just be aware of, maybe they'll ask you a bonus question like that. Usually they'll just ask you to graph the height of the water in the vase versus the time, but perhaps a question such as volume versus time, they'll ask you as a bonus. It's just a straight line if the water is being poured in at a constant rate.